CAMTECH Gwalior is a multidisciplinary centralized training center under the Ministry of Railways. This center develops technical publications and manuals on various railway assets and provides training through seminars and webinars, thereby assisting the maintenance team in improving the reliability and efficiency of the system. This video is related to the maintenance and testing of 132 kV SF6 circuit breaker under the series of electrical assets maintenance in 132 kV to 27 kV conventional railway traction substations. SF6 circuit breaker, HVCB, is a protective device to connect or disconnect the power supply to the circuit during normal and any abnormal condition occurs in the circuit. SF6CB uses pressurized sulfur hexafluoride gas, SF6, to extinguish the arc due to its superior insulating and arc quenching properties. HVCB is used on the primary side of the traction power transformer in the TSS for protection. Construction of HVCB. The main parts of 132 kV SF6 CB are: pole assembly, gas system, base frame, spring operation mechanism, electrical control scheme. Maintenance of HVCB. The maintenance of HVCB is carried out in different periods with different schedules like monthly schedule. In the monthly schedule, perform the activities like checking the insulators, gas pressure, mechanism box, remote and local switch, auxiliary contacts, anti-pumping device, interlock, etc. Half-yearly schedule. In the half-yearly schedule, perform the activities like checking the moving parts, measure the IR value of the pole, checking of main terminal connectors, recording of charging time of the breaker, etc. in addition to monthly schedule activities. Annually schedule. In the annually schedule, perform the activities like checking the plunger for free movement, measuring the operating time, contact resistance, checking gas pressure, etc. in addition to half-yearly and monthly schedule activities. 3-yearly schedule. In 3-yearly schedule, perform the activities like checking the mechanical travels, doors and hinges, movement of rollers, etc. in addition to annually, half-yearly and monthly schedule activities. 6-yearly schedule. This is to be performed when the circuit breaker has completed 6 years of service or 2000 electrical switching operations or 5000 mechanical close-open operations. In 6-yearly schedule, perform the activities like checking and readjustment of operating mechanism, lubricating the mechanical linkage, checking of moisture sealant, gas system setting, compressor, etc. in addition to 3-yearly schedule, annually, half-yearly, and monthly schedule activities. Safety precautions before maintenance. For the safety of equipment and personnel, ensure that switch off the power supply by the opening circuit breaker and isolation to be done by opening isolators, and then provide discharge rods at both ends of CB under maintenance and discharge the residual charges. After this, open all the HV side connections of CB, and also ensure the use of personal protective equipment for safety such as electrical grade shoes, helmets, etc. There are many activities that has to be performed in the maintenance schedule such as visual inspection for any abnormality or cleanliness of porcelain insulator, mechanism box, top and bottom terminal, tightness of hardware and connectors and gasket, condition of open or close, spring charge indication. Functioning check of following: heater, thermostat and lamp. Open or close operation manually as well as electrically. Local and remote switch. Anti-pumping. Capacitor tripping device to be checked. Interlocking with isolator, plunger. Record the following: gas pressure, counter reading, operating voltage of control circuit, Dimensions of CB, mechanical travel. Tightening or cleanness of limit switch and auxiliary contacts. Check moving parts for cleaning and lubrication. Testing of HVCB. As per the maintenance schedule, these tests shall be performed at regular intervals mentioned in this table. Periodicity and equipment required for the tests. Precautions before testing. While performing the tests, following precautions shall be ensured. Insulation resistance test of porcelain pole. The main objective of this test is to know the condition of CB porcelain housing. Insulation resistance can give some information about the integrity of the insulation structure. This is a DC voltage injection test method, and for this test, we require a 5 kV insulation tester. Steps for testing. First, open the connections of both pole terminal connectors. Here we are conducting the test between both terminals of pole when the main contacts are in open condition. Now connect the lead of the line terminal of the tester to the top terminal and the lead of the earth terminal of the tester to the bottom terminal of pole A. After that, check all the connections and select the DC voltage level to 5 kV in the test kit. Now, press the test button. By this, a DC voltage is applied across both terminals of pole A. As a result, leakage current will flow in the circuit, and the tester measure the flow of leakage current and calculate the insulation resistance value by the ratio of injected voltage and measured current. Record the displayed value of IR and compare the value with earlier records or OEM recommendations. If found less, investigate the issue and rectify it. The same test to be conducted for the following combination. Testing data may be recorded in the format given below for evaluation and future reference. Insulation resistance test of control circuit and operating coil. By this test, the quality of the insulation of the circuits and coil is measured. In this test, only 500 volt mega shall be used. Testing data may be recorded in the format given below for evaluation and future reference. Contact resistance measurement (CRM) of main contacts. The contacts in the CB need to be checked periodically to ensure that the breaker is in healthy and functional condition, because poorly maintained or damaged contacts can cause arcing, losing phase, and even fire. This test is done in the close condition of CB under the test so known as the static contact resistance measurement method. This test is a DC current injected method, and CRM kit of 100 ampere or 200 ampere is required for the test. Steps for testing. Here we are testing pole A of a breaker. First, open the connections of both end terminal connectors. Close the main contacts of the breaker under test if it is opened. Connect the positive current lead of the test kit to the top terminal of breaker pole A and connect the negative current lead of the test kit to the bottom terminal of breaker pole A. Now similarly connect the positive voltage lead of the test kit to the top terminal of breaker pole A and connect the negative voltage lead of the test kit to the bottom terminal of breaker pole A. Also, connect the master earthing terminal of the test kit to the equipment earthing. Check all the connections and the setup is ready to perform the test. Now, press the test button. By this, a DC current is injected through the main contacts of the breaker under test. And due to the contact resistance between both contacts, a voltage drop is observed between them. Finally, the test kit measures the injected current through the main contacts and the voltage drop between the main contacts. And test kit calculates the contact resistance by the ratio of measured voltage drop and injected current. Record the displayed value of contact resistance and compare the value with earlier records or OEM recommendations. If found less, investigate the issue and rectify it. Do the same test for other pole of breaker also. Testing data may be recorded in the format given below for evaluation and future reference. Dynamic Contact Resistance Measurement (DCRM) test. DCRM test provides the complete variation in dynamic resistance, which include contact and arcing resistance during close-open operation. Steps for testing. First, open the connections of both end terminal connectors. Connect the positive current lead of the DCRM kit to the top terminal of the breaker and connect the negative current lead of the DCRM kit to the bottom terminal of the breaker. Now similarly connect the positive voltage lead of the DCRM kit to the top terminal of the breaker and connect the negative voltage lead of the DCRM kit to the bottom terminal of the breaker. Also, connect the master earthing terminal of the DCRM and CB analyzer kit to the equipment earthing. Connect the breaker controls lead of tester to the terminal block of the breaker one by one at the DC point, close coil terminal, and both the trip coils terminal. Connect contact timing leads to the breaker terminals. Do the internal connections between the DCRM kit and CB analyzer kit and connect single phase to 30 volt AC supply to both kits. Check all the connections and the setup is ready to perform the test. Now, press the test button through laptop connected to kit. As the test starts, a DC current is injected through the main contacts of the breaker under test. And due to the contact resistance between both contacts, a voltage drop is observed between them. These data are measured by the DCRM kit and sent to the CB analyzer kit, where the analyzer monitors the contact resistance over the time of operation. The CB analyzer plot the contact resistance over the operation time, which gives the realistic variation of contact resistance. Measurement of operating time. Timing test is done on CB for measuring the time required to make and break the main contacts in order to verify the integrity, good working order, and reliability of the breaker. In this test, a breaker timer test kit is required to measure the operating time of the breaker. Steps for testing. First, open the connections of both end terminal connectors. Connect the contact timer lead of the tester to the top terminal and bottom terminal of both the pole of the breaker. Now connect the breaker controls lead of tester to the terminal block of the breaker one by one at the DC point, close coil terminal, and trip coil terminal. Also, connect the master earthing terminal of the tester to the equipment earthing. Check all the connections and the setup is ready to perform the test. Now, select the operation of the breaker and perform the test. The tester gives the trip or close open command to the breaker as selected, and low DC voltage is applied across the breaker contacts by the contact timing leads as an electrical signal to get the status of the main contacts. When the breaker changes its status, the tester senses the change in the electrical signal, and the timer measures the operating time of the breaker under test. Measure operating times of the breaker for these combinations. Testing data may be recorded in this format for further investigation and future reference. Measurement of operating coils resistance. Closing and trip coils are the solenoids, when energized, create a magnetic field that pulls the plunger and operates the HVCB. To check the operating coil resistance, that is, trip and close coil resistance, open both terminals of the respective coil and check the resistance by testing equipment. Steps for testing. First, open the coil side connection of both terminals. Here we are measuring the resistance of the trip coil. Now select the ohm scale in the tester and connect the ohm terminal of the tester to one terminal of the coil and connect the common terminal of the tester to another terminal of the coil. Finally, a current will flow from the ohm terminal to the common terminal of the tester and calculates the resistance of the coil by Ohm's law. Testing data may be recorded in the format given below for evaluation and future reference. Measurement of voltage of operating coils. Measure and record the DC voltage of the trip coil and close coil by DC voltmeter or multimeter for checking of the operating voltage of coils are within the limit or not. Testing data may be recorded in the format given below for evaluation and future reference. Thermography. Thermography is used to predict or identify defects and to rectify the same by carrying out preventive maintenance before in-service failure of equipment. Since analysis is based on the relative temperature of subcomponents instead of ambient temperature, therefore, images of the complete assembly should be taken. Checking should be carried out at the night time, and the concerned component shall be under load. Limit for temperature variation and duration for rectification of issue is given in the table. Testing data may be recorded in the format given below for evaluation and future reference.